Well, hello. Hi, everybody. I'm Sam. I'm a technical designer here at Epic Games, and I'm here to talk to you about the Unreal Editor for Fortnite. Well, more specifically, what I'm here to do is talk to you about making deeper, more complex, more interesting, advanced games in UEFN using Unreal's tech, Fortnite's backend, UEFN's tooling, and a little bit of Verse to tie it all together. And so, let's get into it, because what I've been doing all year is been making games. I figured the best way to demo UEFN is to make a game. It's a game-making tool. So before we move to the latest hotness, I want to just walk you through the games I made this year to sort of show off what UEFN had to offer as it came online. So, back at GDC in March, I made a top-down twin-stick shooter using our new camera, our new third-person controls, and scene graph prefab to build the environment. It's a classic maze shooter, but I added a lot of movement tech from modern games, sliding, mantling, that kind of stuff, and it produced something pretty neat. I was pretty proud of it. However, for Unreal Fest Prague, I wanted to really play to the strengths of UEFN. So I took that same top-down twin-stick movement shooter template and turned it into a 3v3 PvP game with objectives and controllable NPC AI, because I am an RTS designer at heart, and I'm going to put controllable NPC AI into anything you let me do. So that's this, and it was also pretty cool. And you may notice it had a lot more dynamic camera, there was a lot more going on there. And so where do you go from there? What is next? Well, the answer is to bring it all together. And by that, what I mean is I wanted to go back to the PvE design of my original idea, but as a multiplayer game. And I'm an RTS designer, so I wanted to roll in some tower defense concepts. But this is a sci-fi environment, so you're not defending a castle, you're defending a spaceship. And spaceships can move, and that's way more cool. So here's a quick little cut of the thing I built. We'll have a full playthrough at the end, but it's worth just kind of seeing the basics of it so you can understand the kind of game it is. The idea is that you have to get your spaceship from the start of the level to the end. You can start it and stop it, but it follows a linear path. You can capture NPC sidekicks to defend the spaceship, and you can also send them to protect yourself. And because it's a 3-player game, that gives you a lot of tactical options. Then we have multiple enemy AI types, including ones that self-destruct against the player. And if you pull it off, you escape and you win. Yay, lucky you. And so what went into this? It is a 3-player PvE tower defense game. It has dynamic sequencer-driven animation, custom camera and control. The playspace was built with scene graph prefabs, has custom NPCs with unique non-Fortnite visuals and custom AI, has a custom UI, and it's all tied together with Verse. So before we get into real specifics, I do want to talk a little bit about just basic setup. I'm going to gloss over it, bear with me. But setting up this, first things to do, created the experience settings. Said this is a 3-player game, it is competitive, cooperative, it does not have rounds, all the basic experience setup. And then I use a class designer to set up my just custom player class. In fact, I can hop over and show you all that stuff. So I've got, these are all my Verse devices and my various UEFN devices, but I built that to get things going, a class designer. So our player was set up for top-down movement, high speed, and basically a third-person game and a top-down game don't play the same, so I wanted to make sure everything was set up correctly. However, I don't want to spend too much time on the basics. I want to get into our spaceship. So what I'm going to do is talk about how the spaceship works. So the spaceship is driven by a cinematic sequence device. So I have several. Let me drag this out a bit just so you can see what they're called. So a cinematic sequence device called ShipMove. And this is synced across the network. And all it does, if we go to the sequencer, come on sequencer, you can do it. Where is, there we go, sequencer. So all it is an animation moving the ship from A to B. When you hit B, you win. If you blow up before you hit B, you lose. It's as simple as that. However, if I was to jump back to the slideshow for a second, you may remember that there was a lot more motion to the ship than just like a straight transform move. And that is because I'm using layered animation to bring it to life. What that means is I don't have one cinematic sequence device, I have multiples. And those ones are running cinematic sequences that use additive transform tracks. Sorry, long day. They use additive transform tracks, which means that rather than overwriting the transform in the animation, they add to the existing transform. So for instance, these ones of the ship stopping and starting, it's just pitching up or pitching down the ship in an additive way, so it's not resetting its location to the beginning and it's not messing with its angle. I'm also firing off some VFX in the same cinematic. And then you can make it a little more complicated. So I have two damage states for the ship. And each of those is a looping additive animation that is adding basically a double pull-in noise to various axes and angles of motion in an additive way, so the ship starts rocking around. It's also triggering a bunch of VFX to fire in a loop, so it's always exploding. But it leads to this kind of wiggling, dynamic, like, oh no, our ship's in trouble effect, which I think is really pretty cool. And then the final thing that I use this cinematic sequences for are my dramatic endings. So ship escapes, which you might have seen, ship blows up. Not so good. What I love is right there, you can actually see the ship blow up as the game ends. I spent a lot of time on that. And these are pretty simple. Victory is just a standard animation. I know where the ship's going to be at the end, so I animate it leaving. However, when it's destroyed, I need to use an additive animation because I want it to blow up and spiral into the stratosphere wherever it is, not at the beginning. So I use an additive animation for that as well. And one of the key things with all of these, including our sweeping intro sequence, is that none of them use cinematic cameras. They are all using the camera devices in UEFN, mostly the fixed angle camera, to create all these effects. And part of that is because I need the camera to go where the spaceship is, not where the player is. So let's talk about cameras for a little bit. So here in the editor, let's bring up one of my cameras. My camera devices. So you may notice I have a bunch of camera devices. And they are all doing very specific things. Now we have 3 cameras that are automatically added to every player on start. Apologies, 4 cameras. We have your default POV. It's your view of the world, top-down camera. Tried to arrange it for a kind of a 3/4 perspective. And then you have the intro camera, which you may have seen is that cool high-angle view. And you have the endgame cameras for defeat and for the ship escaping. In each case, they are just more fixed angle cameras. The only difference is defeat and escape. I have set to track, as I scroll down way too far, my ship, not the player, because I want it to pan over to the ship because the ship is the focus of the game. You want to see it be destroyed. You don't want to just be like, I guess I lost, because that's not that much fun. So, and then we have the intro camera. And so one of the fun things with the intro cameras is the highest priority. And cameras have priority settings. And so when I activate it right at the end, it means that the last thing you see before the game ends is the high angle shot of the entire station again. It's a nice dramatic end after a dramatic intro. However, there's a little bit more than that because I also have the dynamic game cameras. So I'm going to quickly show you a slide of those. So I have 3 heights of camera. That's the default, added to the player by default. And then I zoom in. And this is for interiors. And I zoom out when you're on the ship so you see a little bit more of the play space. So how do these work? Well, it's actually pretty simple. Why is it not quitting my slideshow? There we go. So the way it works is these cameras outside the default are not added to the player on start. So you see zoom in, zoom out, not added to the player on start, but they're always enabled. They have their own priority settings so that they override the default camera. And what I do is I add them to the player situationally, meaning when you, if I bring up my thing and hide some of this so you can actually see it. So for these, I use mutator devices, the mutator zone device. What that is a device that tracks the player entering and exiting a trigger zone. It can be a circle or a square. And It tracks the player entering and leaving, and you can modify the statistics of the player while they're in there, which is not really what I needed them for, but it's still, useful to have. So what happens is when you run into one of these mutator zones, let me just select one, all I'm doing is going on player entering zone, I'm adding audio, and I'm adding the camera. Simple as that. I add the camera when you enter the mutator zone. When you exit, I leave. So let's see. Zoom in camera, if you look at the zoom in camera settings, all the way down here, it is add to player. On entering these areas, remove from player, on entering these areas. And then the one for the ship is exactly the same. It's just a mutator zone attached to the ship, so when the ship moves, it moves. The one difference is there, I've actually slowed down player movement because I don't want you to go flying off the ship when you jump on it. So that is what that is for. Now, there is one more camera you might have noticed in my little teaser. I'm going to remind you of it right now. So this is what I call my strategic camera, which is a orthographic projection as opposed to a lens simulation camera like these. This is an option we added to UEFN for cameras relatively recently. If you don't know what an orthographic projection is, it's not simulating a lens, it is doing math to basically draw 3D spaces 2D, so your lines are perfectly straight. It gives you a nice clear view of the play space. And how that works is a little different, because obviously I cannot go, oh, well, you've entered this area, so I'm going to bring up the strategic camera. That doesn't work. So instead, to get the SatCam to work, I use a little bit of Verse. So in Verse, I created a player manager device. And what that does, there's a lot of stuff in it, but for the moment, it takes an input trigger called strategic view. That input trigger, let me select it. Let's get the input trigger. So these are input triggers. What they do is they let you override inputs in the game, and you can consume them, which means that the original binding doesn't work, or you can let them be. I consume them. And so what here I did was I overrode what is the aim button in Fortnite, because in a top-down shooter you don't need to aim. And I turned that into my strategic view button. Hold it in, you go into satellite view, release it, you go back. Which is all well and good, except the input trigger will be triggered by any player hitting the aim button, not just the player who did it. And it would be really annoying if you're playing the game and suddenly the camera zoomed out and turned gray on you when you didn't want it to. So for that, I set up the player manager to handle these input triggers. So for the strategic camera, it's actually really easy. All I'm doing is subscribing to their on-camera pressed and on-camera released events, because everything in UEFN is event-driven. I can take those events. One of the fun things in Verse is those events pass an agent. That's the person who actually hit the button. An agent can also be an NPC. NPCs can't hit buttons, so I know it's a player. And so what I do is I can then take that agent and only add the camera to the one who hit the button. The post effects are only added to that player. They only show up on their client. Same with, I changed the audio mix. I have some sound effects that I'm playing, a whole bunch of stuff. And then when you release, it's exactly the same. It's just inverted. So that means you get this cool orthographic camera with all of this nice transition. Like, I'm not doing this with sound, but yeah, the sound drops out, it becomes all satellite, the post effects come in. I have the wrong slide playing. Here is the correct slide. And as you can see, it's pretty effective. It looks really cool, and it's not very complicated to set up. Okay, so now we have, we have a beautiful camera setup. We have a player that we can control. We have a ship that moves. What we don't have is a world for it to move through, like this world. And this world was built with scene graph prefabs. So I'm going to give you a little demo of what those are. So while it's loading in, I'm going to talk about scene graph prefabs. You've probably heard a bunch about scene graph this Unreal Fest, but basically it allows us to use entities and arrange them in a hierarchy and get access to the entire world on an entity level. Entities exist above actors in the overall Unreal hierarchy. They're much more lightweight, but they can also be customized with components, which is really useful. So here you see a bunch of assets from the Talisman demo. If you don't know what the Talisman demo is, it was an awesome demo. It's the MetaHuman downstairs. And if you want to use any of those assets, go to Fab, type in Talisman, audio, props, VFX. That's all I do. I just use their stuff because I'm not an artist, I'm a designer. But to make a scene graph prefab, you have this hierarchy of entities, which can be like static meshes, and then you save it out as a prefab that you can just drop anywhere in the world as an instance. And so what I did was basically turn a bunch of the props from Talisman into scene graph prefabs. So this is a scene graph prefab with a bunch of props in it. It is a series of entities with static mesh components, and that's basically it. That's all it needs to be. And so far, so Blueprint Actor, right? You know, you get stuff, you arrange it in a stack, you add components, you can place it anywhere in the world. And so I built all of these things as prefabs, but one of the fun things with prefabs is they're just entities, which means all of these are prefabs built from my other prefabs. You can stack them in a hierarchy. So for instance, one of these corridors is several floors, several walls, a couple pillars. They're all separate prefabs that have all been turned into one prefab that I can drop in the world. But because it's all inheritance-based, if I want to update the floor, I just go to the base floor and go, oh wait, that's offset a little bit. Let's fix that. And it will fix it for everything that uses it. And that allows me to build out a tile set to build my world. So next, I'm going to open up the actual level design map where I built my world. And here we go. Here is the actual world. And you can see these are all prefabs. Look at that. That is a prefab, that is a prefab, that is a prefab. And all I did was drop them in the world and then lay them out how I wanted. So, select all these different prefabs. However, there is a thing you should know. You could just copy paste them in this layout into a new map, but that's really messy. And there are more efficient ways to do things. So one of the fun things with the prefab, let me just jump back here, is you can do a command called group under new entity with any prefab. And then once you've grouped it under a new entity, you can turn that into a new entity into a prefab asset. And what that means is if I jump over here, this is just a prefab. This is my entire layout as a single prefab. I'm going to open it up. Actually, that's the wrong one. That's the one that is multiple bits of prefab. Let's jump back. But yeah, it is one giant prefab. And that means when I come to lay out my level, let's go to the level design, go back to the main map. Come on, level design map. Okay, let's go back to the main map. And I go to a top-down view. Once it loads in the interim, I will just vamp. But yeah, scene graph prefabs are really useful. They are an experimental feature. They're going to go beta, so you can publish them reasonably soon. But right now they are experimental. If you want to enable them, you do it in project settings. In your project settings, which I failed to select. There you go. So your project settings are there, you would turn them on. So you can't currently publish with these, but you can soon. But if you look at the top of my map from a top-down view, it is literally two scene graph prefabs, one's flipped 180, and offset slightly to create my entire layout. That's it, plus some nifty VFX that I totally stole from the Talisman demo, as I did with this nifty planet. And that gets you the layout. Simple as that. And then, of course, this is the Unreal Engine. It has really powerful tech. So I went through, I propped it out primarily with Fortnite props, some fab props. We have a huge library of stuff in UEFN. I did some fun stuff with atmospherics and fog to create the interior spaces. The interior spaces also have their own post effects. All that kind of stuff to just really sell the space as a cool space station, not just a collection of tile pieces. And that got us the layout. And so now we have a layout, we have a ship that can move across the map, we have a player that can shoot and run around and do all that kind of stuff. And if we were to play the game, we just win because, you know, there's nothing to attack us. And so what I need to do is set up some NPCs. So I'm going to first show you what I needed to do for my enemy AI, is that I needed three kinds of AI. The slide says enemy AI, but the friendly AI is not too different to the range. So I needed self-destruct ones, so it would run at the ship and explode, damaging the ship. And I'll show you how I build that health bar later. And then ranged ones that act like just FPS enemies and harass the player. And then the player recruitable ones would be the equivalent of the ranged ones, but under player control. So my original goal for this was to just, let's use some AI stuff that I'd already done in previous projects, but it didn't really work. And I'll get into that more in a second, but what I want to show you now is how I got those things to spawn in the first place. So I used an NPC spawner device, and I can't spell, NPC spawner device for enemy spawners. And you can see I have ones for ranged, ones for self-destruct. And how are they showing up with my cute little robots? How does that all work? How do I have these custom NPCs? Well, NPC spawner device, unlike our other character spawners like wildlife, guard, creature, all of that, those allow you to modify pre-existing archetypes a little bit, but ultimately are there to designed to spawn Fortnite enemies. But what you can do with an NPC character definition, like one of these, let me just dock this so you can see it a bit better. So NPC character definitions, you can open it up and basically define an entire character. So that includes the type. It has the guard and wildlife archetypes. I'm using the guard archetype simply because it's shooter AI. I need shooter AI. Why would I write that myself? But you could put wildlife or custom, meaning a verse behavior. If you want to write AI entirely in verse, you can. Verse behavior, right there. I didn't do that. And then what I did do is basically override almost every setting in that NPC. Because you can drop in modifiers on NPC character definition, awareness, guard perception, patrol path, all of that kind of stuff, and get them to behave how you want. Because ultimately, top-down shooter and a third-person shooter are not the same thing. You have way smaller field of view, but you can see behind you, or it's just a very different game. So I could not just use our default AI. However, the other thing I wanted was I wanted them to look different. You may notice in the video, they're adorable little robots. And that is not a standard Fortnite character. In NPC character definition, you can just apply a bunch of pre-selected Fortnite characters to it, and it will use those. But me, I wanted to use StackoBot. So if you don't know who StackoBot is, he is the star of a sample project that my team, the tech content team, put out a couple years ago. It's a third-person, non-violent platformer. And I decided to bring StackoBot over to UEFN and give him a gun. Because, that's what you do. So StackoBot became a TackoBot. And so I imported the skeletal mesh, because you can bring a skeletal mesh right in from UE to UEFN. I made 3 variants with the material. So golden one is DefenderBot. That's the one that you recruit. And then the other 2 are AttackerBot. And he's got crazy eyes. He is there to shoot you with ranged weapons. And then we have DestructorBot, who pulses, because that is the universal video game language for I am going to blow up. And that is my basic robots. However, if I was to plug them directly into my NPC character definition, and these are just blueprint actors with a skin, and that's all they are, they wouldn't work, because UEFN does not have an animation set for that character, and I'm using the guard logic. So I need the Fortnite animations to retarget to my character. And funnily enough, all you need to do is create an IK retargeter. And this is an IK retargeter. What it does is it lets you take a source skeleton, like this is standard UEFN mannequin, and then take the skeleton of your own choice, and then have it use IK to dynamically retarget the animations to the other skeleton. And because StackoBot isn't that different, it's another humanoid, its proportions are different, I basically just hit the automatically do this button a bunch of times, and it worked pretty well, because I got that. So if you can see that, they are both using the run animation. I've tweaked StackoBot settings a little bit, so it's not quite the same. I want them a little more cartoony, a little more fun. And then, with that done, All right, you open up your NPC character definition and you go down and add a cosmetic modifier, custom character as opposed to an existing character, plug in your blueprint, retarget from Fortnite character, here's your retargeter, NPCs that use Fortnite animations but are entirely a skeletal mesh that I brought in. So you could bring in your own characters and have them animate, have them be enemies for the player without having to write your own AI and animation, which is really key in UEFN because you don't want to spend forever doing this. You want to get it stood up. Okay, so if I was to spawn these NPCs from NPC spawners, they'd spawn. It would be the same kind of spawning behavior we usually have, where they hang out at the area where they spawn and do the stuff that they do, which would be attack the player if they saw them. Though Destructobot has an attack range of 0 because I'm doing some stuff with them. So Destructobot would just look confused. So what I needed to do was give them some actual logic, and that's where verse comes in. So what you'll see is these are all my NPC spawners. They're divided into waves. I'll get how the waves work in a little bit. But these are my NPC spawners, and each of them has a verse tag markup component that lists the kind of NPC spawner they are. So look at that, enemy spawner, self-destruct. And then I created a verse device called a friendly manager. And that, not friendly manager, because they ain't friendly, an enemy manager. We'll get to the friendly manager in a second. But yeah, so my enemy manager is one Fortnite device, verse device, sits in the world and has a couple basic settings, a couple soft references. But what it uses is it uses those verse markup tags to get every spawner for self-destruct enemies and every spawner for ranged enemies. And then it puts them in an array, goes through the array and subscribes to their unspawned and uneliminated events, because every spawner tracks spawned and eliminated enemies that it spawns. Needless to say, this is very useful. So uneliminated always causes the same thing. It's just removing the guard from the array that I'm storing it in. But unspawned, I am adding them to an array, so I know who my guards are. So I have an array of self-destruct bots, an array of ranged bots. And then let's talk about ranged first, because while self-destruct looks simple, it's actually more complicated. So all I do with a ranged bot is put them in an array, and then I call a function I wrote called findLeashable_player. What that does is it goes through the player array, randomly picks a player from that array, and assigns that to the ranged enemy. And it puts in a leash mode. And so leashing basically says you have to be between X and Y of either a location or an agent. Player's the agent, so they basically just chase the player across the map from then on. Really simple. When they're eliminated, they're removed from the array. That's about it. Not too fancy, but really useful if you just want people who attack the player without having to, have the player find them. And I think that's really key. However, you'll notice the self-destructs, all I'm doing is adding them to an array. So how do they self-destruct? Well, you see this. This is me spawning a suspended function, which means it has a pause in it. And so the suspended function is called chase_ship. It is a loop. And it goes through the loop and then pauses. All the loop does is it tracks an object called ship tracking that I've put on the ship. I literally put a tracking device on the ship so it could be tracked because I'm that guy. And it gets its location, and then it has a follow distance, so it doesn't just all glom onto that one point. And I say that's where you're meant to go, and then I leash them to that location. If they can't find the tracking bot, I leash them to the player instead. This was because of a debug thing, I'll tell you in a sec. But that's all it really is. And then that loop runs every second or two and goes, hey, all of you, ship's there now, go there. That way, if you're moving the ship, they will chase it. It's pretty dynamic, it's very reactive, it's very fast. And it's just a nice, simple loop. However, I had a bug. All the way through this project, I had the gnarliest bug where, for whatever reason, my enemy NPCs that were self-destruct would not attack the player after halfway through the game. And I debugged on my verse. One of the reasons my verse is so pretty now is I went through making sure it was all to standard, couldn't fix it. It turned out the tracking device I put on the ship, because I'm cute, is a little satellite dish, because I thought that would be cute. It's a Fortnite prop. they're destructible. So halfway through my wild action, they'd blow up the tracking device and the game would break. This is why you debug your own work. It's good to do. But anyway, so that is how you get our two types of NPCs. I'm going to bring them up again just since I've talked about them so you can see that behavior. So self-destruct ones, running at the ship, blowing up, ranged ones surrounding the player, shooting them. Question though, how does the ship blow up? Because DestructorBot is just running at it. So let's get into a little bit of that. So the ship, if you can, let me switch back to my ship. If I turn on game view, zoom in a little bit, it has a mutated device on it. It also has a damage zone on it. Let me find the damage zone so you can see it. Where is my damage zone? There we go, my damage volume. So what that does is it does damage to anything inside it, but you can filter by team. And so this ship, anything on the team of the DestructorBot that hits the ship dies. It explodes. I gave it a big dramatic explosion, which, gets you halfway there, right? However, how does the ship lose health? And this is where we get into the next device I built, the Gameplay Manager. So the Gameplay Manager is probably the most complex device here. And what it does is manage the core gameplay loop and the ship. So it's all relatively simple for the ship movement and stuff. That's just a switch you flip, pauses or unpauses the cinematic, and it tracks the end game states. So if the ship cinematic ends, it knows to activate the win state, all of that kind of stuff. But we need to track ship's health too, because it doesn't inherently have health. It's not an actor, a Fortnite character. It's just a blueprint mesh with a point light. So what I do is I have two entries that the player can set, or the user can set, ship health and potential per enemy ship damage, 101. So has 100 health by default, 1 damage by default. One thing I do is I actually scale that damage based on the player count if the user wants, because it can be more fun to have more damage if you have more players. It definitely makes the game less challenging. The other thing I'm doing is I'm doing a few things with the ship health to create ship damage state bounds after it loses 10% of its health. Damage state 1. Damage state 2 is at half health. So that we don't have to get to yet, but I will get to in a second. Just remember that as I move forward. So what happens when the damage volume gets fired? What happens is a routine called Reduce Ship Health is called. And that's just a subscription to the damage zone's enemy destroyed event. That just calls this. So I have a variable to check if the ship is destroyed. If it's false, then I subtract ship health. I subtract the increment from the ship health, so the ship health reduces. I update the UI. So it's worth talking about the UI right now. This is Verse UI. This is entirely written in Verse. What I did was I created a canvas slot, and I created a health bar widget that's a slider. And then I basically added it to the slot, and then I added that to all the players, and thus you get that nifty bar. And so you can write a whole UI in Verse. I just wrote one thing. There's a lot of good examples of that on the Epic developer community if you're interested. But it's if you want to make your own UI, it is not that hard. But yeah, so I call an update UI that just reduces the number that's displayed on the slider. And then if the ship health is greater than 0, I call my cosmetic update case switcher, which is those boundaries I talked earlier about, like lose 10%, lose 50%. I basically go, okay, then I'm going to turn on a switch called damage state 1 with the player, because you have to tell which player flipped the switch. And then I increase the damage state, which is what the case switch uses, so next time it calls it, it'll check the next damage state bounds until you hit the max. And the reason I'm using a switch rather than just triggering the cinematic that is the damage state is this is a thing that I find very useful in UEFN in general. A switch is just a true-false bit flip in the form of a toggle, and it can be player interactable, but you can just make it an invisible thing that is in your world. So what I tend to do in Verse is use a switch and the Verse just flips the switch, and then all the events that happen after that are all on the switch, because that way I can remove things very easily without having to rebuild all my verse and everything. It just makes it more efficient, and also when you're debugging, you have less places to look to go, what's firing that event? But yes, that gets us the damage states. If the ship has, however, no health, or less than no health, then we set ship destroyed to true. That's a variable. And we call this destroy ship routine. And that triggers the endgame loss. It plays the cinematic. It does all of the various things. However, the endgame victory switch, which is activated by the cinematic of the ship moving completed, triggers the ship escape, and then you win. So that is the gameplay manager, but it is worth talking about how it manages player or ship health, because otherwise you can't have a game because your ship can't blow up. You'll just always win. That's not fun. So now I have enemy NPCs. However, if I was to play this now, I would just get my ass rocked, if you excuse my language, because one player, no sidekicks, or even if 3 players, no sidekicks, I'm just gonna lose. There's way too many enemies just charging at me. So I need friendly AI. Oops, that's from the beginning. I didn't mean to do that. It's all right. Here we go. So from the current slide, this is the AI I built for my previous game, for the 3v3 game. And this was my first attempt at sort of RTS AI within a UEFN context. And here I used a flag. And when you hold the flag, they follow you, you drop it, they stay where the flag is. But in the context of this game, it was too slow, it was too fussy. The only bit that really worked was capturing it through proximity. You stand near it, timer counts down, you capture the thing. So I rethought the AI, because in that game, you needed a lot of options for where you could have it go, or if you wanted it to follow you. In this game, you either want it on you or on the ship. It needs to defend you, defend the ship. That's its 2 goals. So I wrote friendlier AI. And that has the same capture logic, though I do admit I rewrote it in verse. And then they have a guard toggle instead of a flag, which means literally I hit the toggle button, they guard the ship. I hit the toggle button, they guard me. That's it. And then this is for each player. So this counts for all the NPCs that they've captured and they control, which leads to, a little bit of complexity, but it's worth talking about how all that works. So let's jump into my final verse device. Sorry, a lot of verse today, but it's pretty useful. And that is my friendly manager that I decided to show you earlier for no reason. So the friendly manager is also relatively complicated. The difference between it and the enemy manager is there is 1 per NPC spawner for friendly NPCs. And the reasoning for that is I need to manage the capture state, which is a timer, a mutator tracking your position. I also need to make sure that a second player entering doesn't disrupt the capture or give them the thing instead of you. A bunch of basic rules for that are here basically on agent enter. I set as a capturing agent, all of that. None of it's that complicated, but basically the idea is you stand near the thing, you capture it, a bunch of lights change color, and then it starts spawning NPCs. So this is the interesting part. I then disable all the capture logic. I set a player as the owning player. And then I use the player manager to update the NPC toggle settings. Because if the player has their setting as false and you capture something at true and it's set to true, you want that to be aligned with the player who captured it so it becomes false. So this calls this routine in the player manager called retrieve NPC state. In the player manager, all I'm really doing is I'm keeping there are up to 3 players in the game, they're in an array. I have an array of the NPC states that matches index values to the player. And all I do is go, this player has captured me, passes the agent, it finds the index value for that player, finds their NPC state with that same index value and returns it, which means I can just set the variable through a function in another verse device directly, and it means that everything is synced. And at the same time, in the player manager, if you do the toggle, you also want them all to be synced. And the toggle, and I'm going to get into how the toggle works. The toggle is another input trigger. This one isn't press release, this is press to toggle. I replaced the build button because you're not building in this game. And so instead, what I have is an input trigger, and just like the other one, there is the issue, what if you hit toggle and you're accidentally controlling your friend's NPCs instead of yours? That would really suck. It's just bad game design. So what I do is I subscribe to the pressed event, and let's go down here to target switch. I get the player that hit that button because I want to make sure I get the right player. And then I call this thing called update player values that does a UI update. There is a UI element for each player that shows their current NPC state. That's the Sam Evangelists, robots are defending the ship thing that slides in. There is one per player. And then I update the spawners, and I contact all of the spawners, which just like the enemy spawners, I keep in an array, and I've just tagged them as friendly. I reach out to them and go, hey, this character is changing their NPC logic value to this. And they go, well, that character doesn't know me, so I'm ignoring it. Or they go, oh, that character owns me, so I'll update my value. And that means every time you press like the Y button on your joypad, it just does that. It goes, hey, are you owned by this player? Toggle your status. But how does the actual AI work? Well, let's go into that. This is kind of an advanced version of how the self-destruct AI works. This is another suspended loop, leash NPC loop, which the difference being that this one does not loop through a whole array. This is specific behavior for each NPC because I needed them to have a little more like individuality, if you were. So I do a bunch of stuff to get the player. I'm like, is this the owning player? I want the owning player of the thing. And then I get their position and I calculate. But this only happens if that logic value is true. And then I just go, here's the position of the player, go there. However, if it's false, I go, is the ship tracking device valid? Useful thing to put in after you found out that it got blown up. If so, get its transform, and then do a little offset from that. I have a ship follow distance. I don't generally like people to cluster right around my target thing, and then I move them to the new position. And just like the other one, this is a loop. So all it's doing is going, hey, am I chasing the player? I'll move to the player. Hey, am I chasing the ship? I'll move to the ship. And so if I run that slide again, you'll see that behavior in action. So I captured it. There we go. It's captured it. There they are. And so now they're defending me. Toggle button. Now they're guarding the ship. Super easy, super simple to do, and very reactive. And that gets us kind of to the last key point of the project. Like we've got enemies, we've got friendlies, we've got a layout, we have a cool environment and art, we have a player that plays exactly how we want, we have a 3-player multiplayer code that works. So what's next? What's next is I show you a complete playthrough of the game with sound. And I will narrate it a little bit so you know what's going on, but I want you to kind of see how this plays out as a total thing. And also you can watch my terrible, terrible skills at the same time. So there is me capturing NPCs. You may recognize this video from a previous slide. I see enemies are coming, take one out, and then go activate the ship. That's just another switch. Activates the switch, activates the ship, I just have it hidden on the ship. And so there, me and my sidekicks, Ambivalent Steve and Jill Without a Jungle, are taking on the enemies. I did put a creature spawner in there just for fun, just to surprise the player. But as you can see, I'm running off, going and recruiting more NPCs. They're flooding back to the ship, so it has a little more defense. The more NPCs there are on your ship, the better defended it is. I close the ship down for a second so we can deal with all these ones running at us without just driving right into them. And then I want to work out what's going on next. And then, what do I do? Wow, Ambivalent Steve really is not doing a good job. So there's me running off because I realized we need more sidekicks. And I'm running down, I'm going to find a spawner. I'm entering an interior space. You can see the camera moved in, the post effects changed. I actually changed the music when you enter an interior space. And also, by the way, most of the music is patchwork. I didn't really do a patchwork demo in this talk. Oh, that was where an explosion knocked me off my ship and landed me on the platform, which was pretty awesome. But yeah, this is all patchwork music that responds dynamically to how you play as it builds up. And you can see all of the enemies coming in to get me. One interesting thing is I actually have waves here. And those are switches. Those switches are activated and deactivated by the actual animation for the ship. As it hits certain points, it calls a switch called Progress 1, Progress 2, Progress 3. What that let me do is turn on or off enemy spawners to create waves and to create a greater sense of, believability in the space. And I win. I escaped. My ship escaped. Dramatic ending. And so at this point, that is the talk, but thank you.